Hi guys, am I audible? Please give a response in the chat box if I am audible. Is my voice clear or are you facing any echoes? Sometimes it happens that you will get some kind of echo in my voice. Is my voice clear? Perfect. So we have a DILR set today, which I'll not say what is a primary concept involved in that. Let me see how many of you can figure out and solve that. So the format of today's discussion is going to be like this. So we have a DILR set with 4 questions. So I'll give you 8 minutes to solve that. I think it can be solved in 8 minutes, or let's say 10 minutes. Why put it at 8 minutes? Let's say 10 minutes. So we'll take 10 minutes to solve that. The timer will be running on the screen so you can see how much time is left. So once you are done with those 10 minutes, then we'll discuss the set and see what is the main logic behind cracking that set. Okay, so that's going to be the format for today. You don't need too much of basics to be able to do this. If you know a bit of Venn diagram concept that we have discussed, you should be able to solve it, but it can also be solved with a lot of common sense. I will discuss the concepts as well. So even if you have not gone through the basic classes, you will still be able to understand this when I discuss this particular concept. So don't worry about it. So now let's get into the actual set for today. Okay, so this is the set. You have 10 minutes to solve. You 8 boys, please take it as 80, not 180. It might not affect many of your answers, but it makes sense to have some consistency here. If you are getting your answers, you can please put them in the chat box. Good number of you have come up with answer for the first question, but can you put your calculation as well? Because I could see some 2, 3 of you are coming with the same answer, but I don't think the answer is right. Okay, the time is up. Let's start discussing this. Okay, let's see how we can approach this question. Let's first try to understand the data that is given in this question. In a management institute, all the students of the first year of the program who had more than 10 credits are eligible to apply to foreign universities for the foreign exchange program. Of the 2000 students, so that's the total number of students, in the first year of the program, 10% of the girls and 15% of the boys had less than or equal to 10 credits. 40% of the students in the first year of the program are girls. So that gives a breakup between boys and girls, right? And every student of the first year who is eligible to apply for the foreign exchange program apply to at least one of the universities, U1, U2, U3 and so on till U9. Table gives a list of the number of boys and girls applying to the different universities. Also given U1, U2, U3 and U4 are universities in Europe and the rest are universities outside Europe. Each student can apply to at most one university, means maximum one university in Europe and maximum one university outside Europe. Great. Now first let's get the breakup of boys, girls and how many of them are actually eligible to apply, right? So if I look at the total number of students, it's 2000. And it is also given somewhere that 40% of the students of the first year of program are girls. So of this 2000, boys and girls is 40% of 2000. So 4 into 2 is 8. So it is 800. This is going to be the remaining 1200 or 60% of 2000. It is going to be 1200. So that is a total number of boys and girls in the first year. But it is also given that only the ones who had more than 10 credits are eligible to apply, right? And it is also given how many of them will not be eligible here. 10% of the girls and 15% of the boys had less than or equal to 10 credits. So those people will not be eligible. So I'll have to remove them from the total number of boys and total number of girls to find out how many of them are actually eligible to apply. So let's do that. 10% of the girls, so 10% of this and 15% of the boys. So 15% of this I'll have to subtract. Right? So 10% of 800 is how much? That is 80. 10% of 800 is 80. So 80 I have to subtract from this. So 720 girls only will be eligible to apply. 15% of 120, 10% of 120 is 120. 15% will be what? 120 plus half of 120. 120 plus 60, 180. So here I'll have to subtract 180. Those are the boys who are not eligible. So it will come to 1020. So this is the total number of boys who are eligible to apply and total number of girls who are eligible to apply. So let me just put that here. Total number of boys who are eligible to apply is 1020. Total number of girls who are eligible to apply is 720. Let me just put here eligible. Eligible boys is 1020, girls is 720. Okay, now let's get into the questions and see how we can solve the questions. So I want to clear this part. This is not necessary anymore. We have got the data here. I'm going to carry this forward into the questions and look at each question individually and try to solve them. Okay, let's get rid of this part. Okay, let's look at the first question. How many boys have applied to at least one university from Europe and one university outside Europe? At least one university from Europe and at least one university outside Europe. It is given that each student can apply to at most one university in Europe and at most one university outside Europe. The question is asking for at least one. So when there is an at most one condition and you're asking for at least, this is actually equal to exactly, because the question in general, it has given at most one university in Europe and at most one university outside Europe only you can apply. And this is telling at least one university. So at least and at most if you equal Europe. So let me add all of this. If you add all these values to find out what the sum is coming to, it will come to 1520. If I add all of this, it will come to 1520. Okay. Now, although it looks like there are 9 parameters here, for a moment it looks like it's a 9 parameter Venn diagram. How am I going to solve it? But if you look at the actual categories here, there are only 2 categories. universities in Europe, universities outside Europe. So it's more like a two-parameter Venn diagram here. Okay, so I can say the two categories that we have are universities in Europe, universities outside Europe. Okay, let C1 be the number of boys who have applied to exactly one of these two categories. That is, they have either applied only to a university in Europe or they have only applied to a university outside Europe. Let that be C1. C2, let that be the number of boys who have applied to two of these categories. Means they have applied to a university in Europe, they have also applied to a university outside Europe. So C1 plus C2. See, anybody who is eligible has to apply to at least one university. Right. So anybody who is eligible either should have applied to exactly one of these universities or should have applied to one university of the first kind, one of the universities of the first kind or one of the universities of the second kind. So C1 plus C2 should give me the total number of boys who are eligible. So that should be equal to 1020. Let me quickly repeat this part in case you are not familiar with the C1, C2 aspect. We have discussed this in detail in Venn diagrams class, but I'm going to repeat this once. C1 tells the number of people who belong to one category. Now, what is that one category? What are the two categories we have? People who have applied to universities in Europe is one category. People who have applied to some university outside Europe is another category. When I say C1, it means the boys who have applied to either university in Europe or university outside Europe, but not both. Exactly one of these categories only they have applied. C2 is people who have applied to both the categories. Means one of the universities in Europe they have applied, one of the universities outside Europe also they have applied. Okay, so C1 plus C2 should be equal to total number of people who are eligible. Of course, we're dealing only with boys here. But why is this coming to 1520? Because it's possible that some of them applied for a university in Europe as well as a university outside Europe. So some of them are getting double counted when I'm going to add all of this. So I can put another equation which says C1, because people who have applied to exactly one university will be counted only once here. But people who have applied to two universities will be counted twice here. Right? So 2 times of C2 should be equal to 1520. These two are important equations. I have discussed them as reconciling equations when we discuss basic concepts of Venn diagrams. So once you go through that, you'll get even more clarity if you haven't gone through yet. So C1 plus C2 is 1020. C1 plus 2C2 is 1520. What is the question asking for? Question is asking for C2. Because exactly one university from Europe and one university outside Europe. So I've got the two equations. Now it is damn simple to get the value of C2. So all that I can do is just do equation 2 minus equation 1. If I do that, C1 and C1 will get cancelled. C2 minus C2 will be C2. That will be equal to 1520 minus 1020, 500. So 500 is the answer for this question. See, I'm doing a lot of explanation here, but in exam, if you're clear with the reconciling equations, all that you will do is add this, get 1520. C1 plus C2 is 1020. C1 plus 2C2 is 1520. By looking at that itself, you'll get the answer is 500. So this question, if you're clear with the concepts, should hardly take you even 1 minute to solve. Okay, this particular question. Please type C, whoever is there in the live session, if you're clear with how we solved this question. There's a bit of lag in today's video, so I'm waiting for your responses. Perfect. Let's move to the next question. Let me clear off whatever is relevant only to this question. We will require some data for the upcoming questions also, so I don't want to clear everything that is there on the screen. Okay, let's look at this question, guys. Second one. How many girls have applied to only one university among the 9 universities? If you had solved the previous question, it's going to be on very similar lines. How many girls have applied to only one university among the 9 universities? So girls data is here. I could add all these values. If I add all these values, it comes to 1300. 720 is the number of girls who are eligible. So I can say C1 plus C2, where C1 is the number of girls who have applied to one category. Now, what are the categories here? Girls who have applied to universities in Europe is one category. Girls who have applied to universities outside Europe is another category. So C1 is girls who have applied either to the first category or the second category. C2 is girls who have applied to both the categories. Okay, one from here and one from here. So C1 plus C2 should be equal to total number of girls who are eligible, which is 720. And why is this coming to 1300? Because some of them are getting double counted. They have applied to 2 universities, so they are getting double counted. So I can say C1 plus 2C2 is equal to 1300. What is the question asking for? How many girls have applied to only one university among the 9 universities? So the question is asking for value of C1. So we have got these two equations here. Let's say this is equation 1, this is equation 2. I can do, let's say you don't want to deal with first C2 and then C1. You can multiply the first one by 2 and then subtract 1 minus 2. So that will get rid of 2 for you directly. Okay, or you can find C2 and then go back, whichever way you are comfortable. So if I do this, if I multiply the first one by 2 and then subtract, so C2 will get cancelled. That's the whole purpose of multiplying the first one by 2. So I will get C1 is equal to, now this will become 1440 as I'm multiplying the whole equation by 2. Right. So 1440 minus 1300, that will leave us with 140 as the value of C1. So answer for this question is 140. Please type C if you're clear with how we solved this question. I'm looking for responses from the people who are there in the live session. There is some lag today, so you will find that I am waiting for your responses for some time. Perfect. Let's move to the next question. Let me get rid of all that is relevant only to this question. Let's look at this one. U9 stresses on gender equality and hence insists that each student applying to the university should have another student of the opposite gender as co-applicant, and any student can be co-applicant for at most 3. So this is important. So anybody can be co-applicant for at most 3 people. What is the minimum number of students who are co-applicants to at least 2 students? It's tricky, this question, because the many tricky words here. At most, minimum number, to at least 2. Okay, let's look at U9 data first. 250, 200. The boys, 250 of them applied to U9. Girls, 200 of them applied to U9. I'm just taking this data here so that we can just concentrate here. Okay, you need not rewrite this when you are sitting in the exam. So 250 and 200. Now, I have to minimize that. That's something that you have to keep in mind. I have to minimize the number of students who are applicants to more than 1. At least 2 students means what? More than 1. So what I'll have to do is I'll have to maximize. Let me put it here. Maximize students who are co-applicants to exactly 1. Okay, so first what I can do is I have got 250 boys and 200 girls, right? So I can form exactly 1 like that. I can form 200 pairs, right? 200 girls, I can map them to some 200 boys. That will make sure that there are 200 people with exactly 1 co-applicant. Once I've done that, once I do that, 200 girls mapped to some 200 boys as co-applicants. That's done. The problem is we have 50 more boys. right? So what do I do with those 50 more boys? So initially it looks like, okay, I can keep it at 200, but I also have 50 more boys. So I'll have to somehow map some of the girls to more number of boys than one, because already all the girls have been mapped to one boy as co-applicant. Now I'll have to map some of the girls to more than one boy. Right? So, and I don't want to map too many like that, because I want to minimize the number of students who are co-applicants to at least 2. Now let's see what is the maximum number of co-applicants that a girl can have. At most 3. So if I were to pick up a girl out of this 200 and assign her one more boy as co-applicant, might as well give her 2 more boys as co-applicant. Okay, because I want to finally minimize the number of students who are having at least 2 students as co-applicant. So what I would do is, when I'm going to assign a girl another boy as co-applicant, I will make sure that I reach the maximum possible co-applicants she can have, which is 3. So some of these girls are going to have 2 more extra co-applicants. Okay. Now, how many such applications are there right now? There are 50 boys who don't have co-applicants right now, and each girl is going to be assigned 2 more co-applicants. So 50 by 2, I need 25 girls out of this to be taken out of this 200 girls. I have to take 25 girls out and assign 2 more co-applicants to each one of them. Okay, what is the question asking for? Minimum number of students who are co-applicants to at least 2 students. The minimum is 25. So 25 is the answer to this question. Please type C if you're clear with this question. Slightly tricky one, this, but I think you should be able to understand this one. I'm waiting for responses of the guys who are there in the live session. Okay, let me see how many of you can give me an answer for this. Instead of at most 3, if I change it to at most 6, then what would be the answer? Instead of at most 3, if I change it to at most 6, what would be the answer? So if I say at most 6, then for those 200 girls, I can assign 5 more co-applicants. So if each girl can be assigned 5 more co-applicants, then I'll have to divide 50 by 5. In that case, our answer will become 10. Okay. Someone wants me to repeat, so I'm going to quickly take you through this process once again. Please try to concentrate, guys. First, we are picking out the data from here, which is not absolutely necessary to write separately. If you're sitting in the exam, if I'm sitting in the exam, I will not do this once again, but it helps me to focus just on this place. So I'm writing this data once again, boys 250, girls 200. Now, I'll have to minimize the number of students who are co-applicants to at least 2 students. So first, I'm trying to maximize students who are co-applicants to exactly 1, because you cannot not have a co-applicant with University 9. You should have a co-applicant. So exactly 1, if I have to maximize only 200 girls, but 250 boys. So I can first try and pair those 200 girls to some 200 boys as co-applicants, right? So it initially looks like, okay, I can have 200, but there are 50 boys who are left out who don't have co-applicants. So now from these 200 girls, some of the girls will have to become co-applicants to more than 1 boy, right? And if you're going to have more than 1 boy as co-applicant, might as well have the maximum number of boys as co-applicant. Why? To make sure minimum number of people have that kind of a situation. Okay, and the maximum number of boys that a girl can have as co-applicant is 3. Already I have assigned 1 co-applicant to all the girls, so I can assign 2 more co-applicants to them. And for the rest of the 50 boys divided by 2, I need 25 girls out of this to be removed, so that each one of them can be applied 2 more co-applicants. Hence, everybody will have 1 co-applicant, at least 1 co-applicant. Okay, let's move to the next question, guys. Let me get rid of whatever is there with reference to this question alone. Okay, let's look at this question. Looks scary actually, looking at the length of the question. But if you had done games and tournaments handout that we discuss in class, you should be able to handle this question. Let's see how to deal with this question. U6 accepted a certain number of the 420 applications. You can see that there are 420 applications for U6 here. U6 accepted a certain number, so we don't know how many they accepted. A certain number of the 420 applications and rejected the rest. The university wanted to appoint a representative of the selected students. Hence, the university decided to conduct a tournament. In each round of the tournament, the accepted applicants are randomly paired with one another and were asked to play a small game. So they are going to be paired randomly. Okay, like two people are going to be put together. The winners of each game proceed to the next round and the losers were out of the contention. The process repeats until the winner of the last round is identified. In case there is an odd number of accepted applicants in any round, one applicant gets a bye and directly joins the winners of the next round, winners of the round in the next round. Okay, so this is a proper knockout tournament situation. This is a knockout tournament situation where once you lose, you're out of the tournament, and then the winners proceed to the next round, and finally you try to decide who is the overall winner. Right. Now, the important part. If at least 7 rounds were conducted to decide the representative, what is the maximum number of applicants rejected by U6? Okay. First, let me find out the minimum number of applicants who are accepted, because the tournament is happening for people who are accepted. So if the final target is to find out the maximum number of applicants rejected, I will modify my target as first of all finding out minimum number of applicants selected. Because total number of applicants is constant, it's 420. So if I find out the minimum number of applicants who should have been selected, I can subtract that from 420. I will get maximum number of applicants who should have been rejected. Okay, so how do I get minimum number of applicants who should have been selected? It is given 7 rounds were conducted. At least 7 rounds were conducted. Now, there is a relation between the number of people involved in a knockout tournament and the number of rounds that you should be conducting. So it goes like this. If there are n people in a knockout tournament, then the number of rounds that will be conducted can be written like this. That is, if you can place n between 2 consecutive powers of 2, the higher power you have, the index of the higher power of 2 you have, that will tell you the number of rounds that are required to be conducted. Okay, for instance, let's say I have got 8 people. Okay, so if I have 8 people, then I can put 8 here. So that will be 8 will be between 2 to the power 2 and 2 to the power 3. Right? 8 is between 2 to the power 2 and 2 to the power 3. So there I can confirm that 3 rounds have to be conducted. So in the first round, what will happen? As there are 8 people, I will have 4 matches. Right? So first round I will have 4 matches and I will get 4 winners. So in the second round I will have 2 matches. I will get 2 winners. In the third round, the 2 winners of the second match will come and there will only be 1 match. With that, I'll be able to decide my winner. So that's how this whole situation is going to work. Okay. So if you can place your value here, the number of people between 2 consecutive powers of 2, the higher power of 2 will be the number of rounds. So as it is given, at least 7 rounds were conducted. So let's find out what is the minimum number of people you require for 7 rounds. So what is the maximum you can have if there are 6 rounds? If there are 6 rounds, then I am looking at some number here, the maximum possible number here. If I am allowed only 6 rounds, I'm looking at the maximum possible number here. So what is the maximum possible number here? It can be equal to 2 to the power 6, right? Which is 64. So for 6 rounds, the maximum number of people I can have is 64. So the smallest number of people for whom I will be forced to go to the 7th round is what? 64 plus 1, 65. So the least number of people you should have so that you will require 7 rounds is 65. Because if it is 64, I can still manage with 6 rounds. So one more than 64 if I go, that will require the 7th round. So as at least 7 rounds were conducted, I can take 7 rounds were conducted, because that will help me to minimize the number of applicants selected. And if 7 rounds are conducted, 64 plus 1, at least 65 applicants should have been selected. Okay, now let's actually answer the question. The question asked me maximum number of applicants rejected by U6. The total number of applicants is 420. So 420 minus 65. That will give me 355 as the answer for this question. Please type 4 if everybody is clear with how we answer this. I'm so happy some of you actually got the answer while I was discussing. Very good. Pranay, Gaurav, very good. Type 4 if everybody is clear with how we solved this question. Great. With that, we have come to the end of this discussion. I hope you liked the set. And before you exit, please do like this video in case you like the way the session went. It helps us to reach more people. And also do leave a comment, not in the live comment, do leave a comment below the video, because we are somehow losing the live chat. So do leave a comment below the video in case you liked the set and if you found any of these questions interesting. Probably you can tell which question you found interesting. Okay, you can put a comment there. It helps us to reach more people. Okay, there are some questions I'm going to answer. Saugand is asking me, please repeat the logic once again. Okay, let me quickly repeat this, guys, in case you did not get this. Okay, now this particular logic, okay, the one that I'm dealing with here, let me just show which logic I'm speaking about. Okay, this particular logic, this is something I have dealt with in games and tournaments handout that we deal in our classroom session. Okay, where if there are n people in a knockout tournament, and if you can put them between 2 consecutive powers of 2, the higher power of 2 will be the number of rounds. Okay, the question says there are at least 7 rounds, maximum number of applicants rejected. As the total number of applicants is a constant, maximum number of applicants rejected can be found if I can find out minimum number of applicants selected. Now, if you're wondering why the hell are we doing that? We are doing that because the tournament is happening for accepted people. So it will be better to deal with accepted first and then later find the rejected. So minimum number of accepted or the selected applicants I'm trying to find out first. As it is given 7 rounds were conducted, at least 7 rounds were conducted. I will keep it at 7. I will not go for more than 7, because if I go for more than 7 rounds conducted, that will increase the number of people selected. That will not give me the maximum number of rejections. So although the question says at least 7 rounds were conducted, I'm going to assume 7 rounds were only conducted. Okay. So if 7 rounds were conducted, what is the minimum number of people that should be there for which 7 rounds will be necessary? Okay. So if 7 rounds will be necessary, based on this expression, let's see what is the maximum for 6 rounds. For 6 rounds, maximum is 64. So if 7 rounds were necessary, they should have had one more than 64, because with 64, I can still deal with just 6 rounds. So 7 rounds were necessary means there has to be at least 65 people. So at least 65 should have been selected. You can subtract that from 420, that will give you 355. Okay, someone is asking, what is the range of this set out of 10, 9 being cat level? See, I can say if you know the C1, C2 logic, it's not very difficult. So definitely some people will solve it. So on a scale of 10, if 9 is cat level, I would say this is coming around 9 to 9.5. So if it comes in cat, maybe people will say it's a tough set. Some people will still solve it, but some people would say it is a tough set. So I would not say it is not solvable. It is definitely solvable, provided you have solved something similar to this. Something similar to this we have solved, you'll be able to crack this. Okay, how many of you felt that the last question that we solved looks scary, but once you get to the heart of it, it's actually something very similar to what we've already solved? Any of you are there in the live session, I'm looking forward to your response. Those of you who have solved games and tournaments handouts that we have discussed in the course, you must have felt that this question looks scary, but once you read the question, even before you finish reading the question, you will realize, hey, I know how to solve this thing. If you have solved games and tournaments, knockout logic. Okay. So sometimes questions look scary, but you will be able to answer them if you understand the basic logic that is being tested. Okay. Awesome, guys. So yeah, in fact, this could actually be the easiest if you know this particular logic. This question can become easiest if you know this particular logic. Great. So please like and leave a comment below the video, not as a comment in the live session. We are losing the comments in the live chat. I'll have to figure out why. I'll catch up with you guys on Monday morning. Okay, tomorrow, Sundays, we don't have this session. So Monday, we will catch up again at morning 8 o'clock to discuss. See you guys. Have a great day.